call this polynomial? What's its name? It is a trinomial because it has three terms. What else can we call it? What kind of trinomial? Quadratic because it's degree 2. Its highest exponent is a 2. To factor it, we bubble method it, which means write it as two binomials. Now, to get this x squared, don't you just put an x in each one? Because when you FOIL, x times x would produce the x squared. Okay, then to get our numbers, we have a little method. We have to add up to the middle term, which is 16, and multiply to the last, which is 63. So, what are some numbers that multiply to 63 besides 63 and 1? What are some other factors of 63? 8 what, though? 8 times 9 is 72. What? 7 and 9 multiply to 63. Could you get a 16 with a 7 and a 9? Yeah, 7 plus 9 is 16. So those are our numbers. Now, if they're supposed to multiply to a positive and add to a positive, then both of them need to be positive, and that's your answer. Now, would it have been okay had I written x plus 9, then x plus 7? Yes, it doesn't matter which factor you put where. Okay, number 3. R squared minus 5r minus 36. Okay, we're dealing with another quadratic trinomial that they want us to factor. So we write it as two binomials. To get r squared, we would have to have an r times an r. And now we're looking for two numbers that add up to and multiply to. Okay, well, whenever you're multiplying and you get a negative answer, what do you know about your signs? They have to be opposite. Because think about it. If you had a positive times a positive, that would give you a positive. If you had a negative times a negative, that would give you a positive. So to get a negative, you have to have opposite signs. Now, what are some numbers that multiply to 36? Okay, is that going to make a 5? So let's think of other options. You were adding some. 12 and 3 wouldn't make a 5 though. 9 and 4. Okay, now, but they have to add up to a negative 5. So is it a 9 minus 4 or a 4 minus 9? 4 minus 9 if you want it to be a negative up the middle. Okay, number 5. What's different about number 5 than the first two problems we just did? Right, its leading coefficient is 5. We've only been dealing with leading coefficients of 1. Anytime your leading coefficient is greater than 1, what do you check for? Starts with a G, ends with an F. Greatest common factor, GCF. Okay? Is there a GCF in this trinomial? Is there a number that we can pull out of all three terms? 5. You can pull 5 out of 5, 20, and 160, right? Now, when you're pulling out a GCF, you're basically dividing it. What's 5r squared divided by 5? Just r squared. Bring down the minus. What's 20r divided by 5? 4r, and then bring down the minus. What's 160 divided by 5? Right. Okay, now that we've GCF'd out that 5, haven't we just left a quadratic trinomial that we can use the bubble method to factor? Okay, but you have to remember to continue pulling down that 5 because it is part of the final answer. So now we're looking for two numbers that add up to negative 4 and multiply to negative 32. Well, what will your signs be if you're multiplying to get a negative? Opposite. What are some factors of 32? Okay, you think you can get a 4 with an 8 and a 4? Okay, does it need to be 8 minus 4 to equal negative 4 or 4 minus 8? 4 minus 8 to get a negative 4. And so that's the final answer. Just remember, you always have to keep pulling down the GCF as part of the final answer. Okay, number 7. So far we've only been dealing with trinomials. Now we have a binomial. Now, isn't the middle just missing? Like, see how this one went from the square term to the r to the first term to the constant? and this one goes straight from the square term to the constant, that's because this term of it canceled out. That's because this is a special case. Does anybody remember what this is called? It's 4 words. Remember, it's called a difference of two squares. Difference because it's subtraction. Two squares because both of these are perfect squares. The reason that n squared is a perfect square is because it can be obtained by doing n times n. The reason that 9 is a perfect square is because it can be obtained by doing 3 times 3. But for it to be a negative 9, you have to have opposite signs. Not for this one. Now, let's talk about why there's no middle. Think about it. If you were to FOIL this, the n times the n would give you the n squared, and the 3 times the negative 3 would give you the negative 9. But what about the outer and the inner terms? The outer would produce a negative 3n. The inner would produce a positive 3n. So what happens there? They cancel out. That's why this is known as a special case. Okay, if you recognize right away that this is a difference of two squares, then it's pretty easy to get your answer because they're almost identical with the exception of the signs. Okay, now what about number 9? What would we call that kind of problem? Right, a sum of two squares. Because this time we're adding, so that's why it's called a sum, but both of these are perfect squares. Remember, a perfect square is when you can multiply a number by itself to get it. Like, what could we multiply by itself to get 4x squared? 2x and 2x, right? And then what can we multiply by itself to get 25? 5 times 5. Okay, but here's where it gets a little tricky. Because this time it's a sum of two squares. So, how are we going to get a positive 25 when we multiply 5 times 5? Right. Just think about it. You can't do two positives because, well, the middles cancel out. And you can't do two negatives because the middles will cancel out. For the middle term to cancel out, you have to have opposite signs. However, that poses a problem for us because it's 5 times negative 5, positive 25. No, so anytime you're dealing with a sum, you have to put an I because when you do 5i times negative 5i, what does that equal? And what does that squared equal? Negative 1, which makes that a positive 25 like we wanted. Okay, so anytime you're dealing with a difference of two squares, it's pretty easy. But with a sum, you have to remember to put the I so that that number will end up a positive like we wanted. Okay, number 11. What did we do first on number 11? Okay, pull out the 3 because that's called the GCF. Okay, when you pull out a GCF, you're dividing it out of the polynomial. What's 3n squared divided by 3? Right, and then bring down the minus. What's 30n divided by 3? 10n. Bring down the plus. What's 72 divided by 3? 24. Now, don't we have a quadratic trinomial that we can bubble method? But just remember, continue pulling down the 3. So this time, we're looking for two numbers that add up to a negative 10, but multiply to a positive 24. So what are your signs going to be? If you're multiplying to get a positive? Two negatives. You could have either gone with two positives or two negatives, but in this case, they have to be negatives to add to a negative. What are some factors of 24 that would also add up to 10? 6 and 4. 7 and 4 is 28. Okay, number 13. Any ideas where we'll start with number 13? Well, yeah, but is there a GCF? There's not the same thing in both of those? 2. And what else? Both of them have at least one n, right? So you can pull out 2n as the GCF. Now, when you pull out a 2n out of a 2n squared, what do you leave? Just an n. And then bring down the plus. When you pull 2n from 2n, what's 2n divided distribute this back out, isn't 2n times n 2n squared? And isn't 2n times 1 2n? So that's how you can quickly check, did you factor it correctly? You can distribute it back out and make sure it matches. Okay, and then you're done, because this can't be factored any further. Okay, now turn to the back. Solve each equation by taking square roots. Okay, number 14. X squared equals 25. Anytime you have an x and they say solve, they want you to get the x by itself. Well, what is currently keeping that x from being by itself? The little 2, the square. How do you get rid of a power of 2? No, that's how you get rid of it. Square root it. Remember, you would only divide if it were times 2, but this one's squared, so you square root it. And then we square root this side, so we end up with x equals, okay. However, I know since this problem is squared, that we have two answers. One answer is positive 5, and the other answer is negative 5. Now let's talk about y. What is 5 squared? What's negative 5 squared? Positive 25, because that negative times that negative still becomes positive. That's why both answers are right. That's why you have to put a plus or minus. Okay, number 16, what would I do first? Subtract the 4. And so I end up with a squared equals, okay, now to solve for a, what do I do to both sides? Square root it to get that squared to cancel, and I end up with a equals plus or minus 10. Okay, number 18, what would I do first? Right, this x squared is being multiplied by negative 10, so I need to divide by negative 10. So what is negative 1,000 divided by negative 10? 100. Now it's looking just like the last problem, so our answer is going to be x equals plus or minus 10. Okay, number 20, what do I have to do first to get the n by itself? Add the a to the other side. And so then I end up with n squared equals negative 7. Now to get n by itself, I got to get rid of that exponent. How do I get rid of that? Square root it. And so n equals, is the square root of 7 a perfect square like the rest of them have been? So just leave it in there. But since it's negative, I and then plus or minus. That goes on all of them. Okay, now 22 and 24 say solve each equation with the quadratic formula. Does anybody remember the quadratic formula? Okay, what is it? Anybody? Negative b plus or minus square root b squared
minus 4 times a times the other.
right. Okay, now the reason we need the quadratic formula is because not all quadratics can be factored. Like if you look at number 22, you're like, well, I can't go straight to the bubble method because there's a number in the front greater than 1, and I can't pull out 5 because 5's not going to come out of 5, 4, and 33, is it? So that's why we have a need for the quadratic formula, because we can't factor that. Now, to utilize the quadratic formula, you kind of have to know what to plug in a, b, and c. So when we go down to 22, what's the a? 5. What's the b? And the c? Right? Okay, I'm going to make myself a little space because these problems take some room. So now when I go to plug it in, what will it look like? And what is 2 times 5? Right, we're just going to skip straight to that. Okay, now, what did I tell y'all you should do next in the simplifying process? just the part under the radical. So just type in 4 squared minus 4 times 5 times negative 33. Don't type in the actual square root, just type in everything under it. Okay, what did it simplify to? Nobody typed it in? 676. Okay, now that you've simplified it to one number and you see that it's positive, go ahead and take the square root of 676. Okay, how did we get a whole number? Why was it a whole number? Because 676 is a perfect square. Okay, now watch, because a lot of kids get confused here, so you really need to watch. Negative 4 plus 26 is, what's negative 4 plus 26? And what's 22 over 10? 11 over 5, or if you typed it in, it might tell you 2.2 as a decimal. Either one's acceptable. Now, okay, so look, I did negative 4 plus, now I need to do negative 4 minus 26. And what's that? Negative 30, and what's negative 30 over 10? Negative 3. So those are your answers, 11 over 5 and negative 3. And remember, 2.2 is the decimal value for 11 over 5. Okay, number 24. I'll give you a second to copy this. Okay, number 24. Okay, we're also using the quadratic formula for this one because we can't factor it. So what's the A? 6. What's the B? And what's the C? Okay, so when we go to plug it in the formula, what will it look like? Okay, why is it positive A if the formula is negative B? Because it's already negative. So a negative negative A will become positive A, plus or minus the square root of squared minus 4 times all over 2 times, which is 12. Okay, now go ahead and simplify what's under the radical. Type in negative 8 squared minus 4 times 6 times 3. And guys, the parentheses are very important. If I write them, you need to type them. Okay, I'm hearing most of you say that you got negative 8, which is correct. Now, remember in the previous problem, we got the square root of positive 676, which simplified to 26 because there was a perfect square. Is the square root of 8 a perfect square? No. Just think about it. Is there a number multiplied by itself that would make 8? No. Okay, so for that reason, you have to take 8 to the side and factor tree it. What are the factors of 8? Okay, does 4 break down? So another set of 2's. Okay, and then circle, get rid of this one, pick out this one, and then that one gets to stay in the house. But keep in mind when you write it over here, it was a negative 8. So what does that make? Right, 2I square root 2. Now, the reason that we simplified the square root of 8 is 2 square root of 2 instead of just typing it in and giving the decimal value is so that now we can reduce. Because like if you had just written the decimal value, you wouldn't have been able to reduce it. What's 8 over 12 reduced to? 2 over 3. And then plus or minus, what's 2 over 12 reduced to? 1 over 6, and then I root 2, and really that 1 is not necessary. You can write write it, but if you were taking a multiple choice test, it wouldn't be there. Okay, so we basically reviewed every single thing I taught you in Unit 4B before the break. So it's your job to work all the other problems for practice, because tomorrow we're going into the rest of Unit 4B, and we won't practice this again until the review day before the test, which is in 2.5 weeks. Does everybody understand? Okay, so be working on this. While you're working on it, I'm going to call you up and give you your EOC score from last year.